Hello viewers, in today's class we are going to solve yet another important and conceptual problem from derivatives, right? So here we have a problem which is given as a function is given as f of x is equal to tan inverse, and inside the bracket we have a square root of 1 plus x square minus 1 over x. Then we have to find the derivative of f of x when x is equal to 0, right? So here we are given a function in this form, and we have to differentiate it, and then we have to find its value, the value of the derivative at x is equal to 0, right? So let us start. Now viewers, in these type of problems, what we usually do, we make use of substitution method, right? So here the function is given as tan inverse, and inside the bracket we have an expression in terms of x, right? So we can will not differentiate it directly, right? So first step is to simplify this expression by making use of a proper substitution, right? So let us first search for the proper substitution. So here the proper substitution is x is equal to tan theta, right? So what we will do, we'll substitute x is equal to tan theta here, and then we'll simplify this expression, right? So f of x becomes equal to tan inverse, and here we have square root of 1 plus tan square theta, because we'll take x equal to tan theta here. Then we have minus 1 divided by tan theta, right? Okay, now here we'll make use of some important identities from trigonometry, right? So we know that 1 plus tan square theta is equal to secant square theta, right? So the square root of 1 plus tan square theta is now equal to secant theta. So now we can write this expression as tan inverse. Here we have secant theta minus 1 divided by tan theta, right? Okay, now this expression needs further simplification, right? So what we will do, we'll replace sec theta by 1 over cos theta, right? And tan theta by sin theta over cos theta, right? So what we are doing here, we are given an expression, and we are making this substitution, and first we are trying to simplify this expression, right, by making use of this substitution. So now let us simplify it. So we have tan inverse, and here we have 1 minus cos theta over cos theta by taking LCM here, and in the denominator we have sin theta over cosine theta, right? Okay, so now this cos theta and this cos theta get cancelled, so we are left with f of x is equal to tan inverse and 1 minus cos theta over sin theta, right? Okay, so now we have the expression for f of x like this. Okay, so now we'll further simplify this expression, right? So again we'll take help of trigonometry, and we know that cos of 2 theta is equal to 1 minus 2 sine square theta, right? So this is a famous identity from trigonometry for cosine of 2 theta. See here we want to have 1 minus cos theta, right? So what we will do here, we'll replace theta by theta over 2, right? So what we will get, we'll get cos of theta is equal to 1 minus 2 sine square theta over 2, right? So 2 sine square theta over 2 is equal to 1 minus cosine theta, right? So for 1 minus cos theta, we'll replace this 1 minus cos theta by 2 sine square theta over 2. Now similarly in the denominator we have sine theta, right? So what we will do, we'll make use of this identity, that is sine 2 theta is equal to 2 sine theta cos theta, right? But here we want to have sine theta. So what we will do, we'll again here we'll replace theta by theta over 2. So sine theta is equal to 2 sine theta over 2 cos theta over 2, right? So for sine theta we'll write this expression, for 1 minus cos theta we'll write this expression, right? So now f of x reduces to tan inverse, and here we have 2 sine square theta over 2 divided by 2 sine theta over 2 cos theta over 2, right? So now see, this 2 and this 2 get cancelled, sine theta by 2 and sine theta by 2 get cancelled, so we are left with 1 sine theta over 2 in the numerator, right? So we have tan inverse, and here we have sine theta over 2 divided by cos theta over 2, right? So now sine theta over 2 divided by cos theta by 2, it becomes tan theta over 2, right? So f of x is now equal to tan inverse, and we have here tan theta over 2, right? And from the inverse trigonometric function, tan inverse and tan, these two get cancelled, and we are left with simply theta over 2, right? And provided that this belongs to the principal branch of tan inverse, right? So f of x is now equal to theta over 2, and from here theta is equal to tan inverse of x, right? So here we have half, and for theta we can write tan inverse of x, right? So finally we have f of x is equal to half tan inverse of x, right? So initially we had this function, we have reduced this function to this form by making this substitution, right? So now we can easily differentiate both sides with respect to x. So the derivative of f of x is f prime of x, which is d by dx of half tan inverse x, right? So we can take half outside, and the derivative of tan inverse x is 1 over 1 plus x square, right? So the derivative of f of x is f prime of x, which is equal to half times 1 over 1 plus x square, and now we need to find f prime of 0, right? So what we will do, we'll take x is equal to 0 here. So we have f prime of 0 is equal to half, and we have 1 plus 0 square, right? Here we'll take x equal to 0. So we have half, and here we have 1 over 1, that is half, right? So viewers, the value of f prime of 0 is equal to half, and this is how we can solve this type of